Welcome to the Earth SciShow podcast, where we explore the wonders of the Earth and the science behind it. Today, we're going to talk about a hotly debated topic in the world of geology, the Great Flood. Specifically, we'll discuss the geological evidence of sedimentary rock layers found across continents, such as that at the Grand Canyon, and also talk around the fossils and how it relates to the flood theory. And if you enjoy this kind of content, please consider subscribing and following and hit that notification icon so you hear about the latest episodes as soon as they're published. So what are flood geologists and who are the old Earth geologists? Well, flood geologists believe that layers of sedimentary rock found at the Grand Canyon and other places around the world are evidence of the Genesis flood. They argue that the marine fossils found in the rock layers suggest that they were deposited by high levels of water that covered the continents during the deluge. However, old Earth geologists disagree with this theory. They explain that the character of the rock layers is not surprising, and it's a result of continuous movement of oceans and continental plates both laterally and vertically. Flood geologists have different opinions on how deep or high the flood waters rose over the continents. Some imagine the water rising above the present heights of mountain ranges. Others suggest that during the late stages of the flood, the continents were lifted up as water drained into the deepening ocean basins. And the reason for the difference in opinion is due to the lack of evidence that there was a flood to begin with. You see, ocean and continental plates continuously move both laterally and vertically. We can actually measure this movement in real time by GPS today. As a consequence of this, we often find continental crust thinning out and sinking below sea level. One example of this is Death Valley, and the other one is the Dead Sea. Conversely, there are many places on the Earth today where very thick deposits of sediment and sedimentary rock are accumulating on the continental crust below sea level. Examples include all of the wide continental shelves surrounding the Atlantic Ocean and Gulf of Mexico, and the North Sea between the United Kingdom and Norway. The weight of the sediments causes the crust to sink, basically getting heavier, allowing more accommodation space for more sediments to be deposited. Ultimately, this can allow miles of sediment to accumulate, which is why it's so expensive for the oil and gas industry to dig in those basins. As continents converge in the future, these sea deposits containing abundant remains of sea creatures may be lifted above sea level, just like they did in the layers of the Grand Canyon. The point is, many modern-day seas are on continental crust, and none of the sedimentary rock layers in the Grand Canyon resemble deep ocean deposits, therefore allowing us to use these modern-day analogies for what happened in the past. One of the extraordinary claims by flood geologists is that there are large layers of sedimentary rock covering vast areas of continents. And while many sedimentary rock layers do cover vast areas, there is no single layer that covers an entire continent from one end to the other, as the flood geologists imply. And rather than finding evidence of one massive deluge, geologists find abundant evidence of multiple periods of rising and falling sea level that varied as much as 120 meters high and lower than present. It's a combination of the low-standing continental crust and high-standing sea level that results in these sedimentary layers. The sedimentary rocks deposited in the Grand Canyon were caused by sea level repeatedly rising and falling. Each rise in sea level, shorelines moved inland, along with deposits of sand, shale, and limestone that comprise the geological formations we see in the canyon today. And a key note there is different stratigraphy and sedimentology, each one deposited in a different environment. We'd be ignorant as geologists to say that there aren't any turbulent deposits in the Grand Canyon. There definitely are, but they are far and few between. Most of the sedimentary rock layers there formed in very shallow water or just above sea level, which just wouldn't be possible with the flood geology theory. And evidence of this is shown with the abundant sedimentary structures such as mud cracks, raindrop prints, ripple marks, and crossbedding, all which can be seen if you just took a walk through the canyons. Now we've spoken around the basics of sedimentology and how the layering of the Grand Canyon doesn't match up to the flood geology theory, let's talk about the fossil evidence. Ken Ham frequently tells audiences that the worldwide flood resulted in billions of dead things buried in the ground. And for those who aren't aware, Ken Ham is by far the most prominent young Earth creationist out there. He describes the sea creatures being swept along the turbulent floodwaters and deposited, tsunami style, along with the sediments forming the rock layers we see in the Grand Canyon. And whilst he preaches this to all his followers, there is not one shred of evidence that goes with his claim. Rather than finding evidence of a single global catastrophe, the fossils of the Grand Canyon provide one of the clearest pictures of a long history of changing environmental conditions and life forms. For example, if these animals and sea creatures were violently transported, there would be a mixture of organisms from dissimilar environments. And in fact, we find that most fossils in the Grand Canyon are actually found in association with other fossils from coherent systems, therefore finding no evidence of turbulent deposition. For example, We find discrete layers in the Grand Canyon where only terrestrial fossils are found. These are typical with riverine environments with no evidence of chaotic mixing with marine organisms. Most significantly, there is not a single mammal, bird, dinosaur, or flowering plant found in fossilized form in any of the rocks in the Grand Canyon. Yet there are abundant fossils in the younger rocks of the Grand Staircase, which is an immense sequence of sedimentary rock layers that stretch from south from Bryce Canyon National Park all the way into the Grand Canyon. Then why don't we find the fossils there? If the flood came and the flood existed, then we would see fossils in the Grand Canyon as well. There seems to be an inconsistency with the flood geology arguments. On the one hand, they say that the perfectly preserved, delicate fossils are evidence of rapid burial by a catastrophic flood, and then on the other hand, broken fossils show evidence of a very violent catastrophic flood. To say that both fine preservation and fragmented preservation are convincing evidence of the same phenomena is no evidence at all. Now, of course, there are variations in the preservation observed, but in each case, the character of the fossil is consistent with the specific environment in which it was deposited. For example, it is significant that plant fossils are missing from most layers of rock in the Grand Canyon. This is consistent with the observation that much of the rock in the Grand Canyon is marine in origin. And where plant fossils are found, they are consistent with the depositional environments such as the riverine environments in terrestrial areas. One of the main questions is, why does the Grand Canyon have no evidence of flowering plant fossils? How could a global flood with tsunamis sweeping across the continents fail to deposit a single grain of flowering plant pollen in the entire sequence of the Grand Canyon layers? It makes far more sense that these layers were laid down during a time when flowering plants were not yet found on Earth, which opens another can of worms, suggesting that the Earth is billions of years old. But that's a different topic for another podcast. And one of the fundamental techniques in geology is looking at trace fossils, which goes beyond just the stony remains of animals and plants. Trace fossils describe past activities of animals when they were alive. And we can identify trace fossils and know exactly what creature created them because we have analogies of modern-day oceans and terrestrial environments. For example, we find trilobite feeding marks which indicate a calm, shallow sea bottom, which is complete contrast to the chaotic flood environment. We find preserved footprints and tail marks that vertebrae made while walking over wet sand dunes. How could these have been formed and preserved in the middle of a chaotic worldwide flood? And we can go smaller. There are actually preserved tracks and burrows of spiders, scorpions, millipedes, and more. So yes, there are billions of fossils in many of the Grand Canyon rocks, but these fossils are not the jumbled mess that one would expect from a turbulent global flood. Rather, there is an amazing, predictable order and succession of fossils that can be explained by changes in life forms over many, many years. Coming back to the sedimentology, there are some flood geologists that argue that there are sediments found in regional scale rock formations like the Coconino sandstone that must have been eroded from distant sources and carried long distances, then rapidly deposited by fast-moving water. They claim that no known sediment transport system is capable of carrying sand across the entire North American continent during its required millions of years. But luckily for us, there is a well-understood sediment transport mechanism: rivers. A modern example would be the Mississippi River, which carries sediment from the eastern Rockies and the western Aleutians to the Gulf of Mexico. We can go one step further. The Coconino sandstone is a rock unit that is distinguished by crossbedding, which are dipping parallel layers within the formation that are seen in modern-day sand dunes. We also find evidence of trace fossils such as animal footprints. A direct example in the modern world today would be the Namibian desert in Africa. Dry sand dunes don't fit in the middle of a year-long global flood, so flood geologists argue that these crossbeds were formed through underwater processes such as migrating sand waves. Now, whilst this is true, you can get crossbedding from very slow-moving currents. However, where this breaks down is flood geologists say that all the Paleozoic and the Mesozoic strata in the Grand Staircase and Grand Canyon were deposited in 1 year during the flood. This means that the Coconino would have had to have been deposited in a matter of days, and using some simple math, it just wouldn't work with 4 miles per hour currents. We would need a wall of sand hundreds of feet high and hundreds of miles wide sliding laterally as it spreads across the continent. Again, something we don't see in the geological record. And because they can't refute these claims, they're now turning to what they call underwater gravity currents, whereby these currents have moved huge quantities of stockpiled sediment and fossils from higher areas, leaving behind deposits that happen to have all the features found in sedimentary rocks. This includes the complex crossbedding found in the dunes, intact fossil communities, and even buried stream channels. They say that the rapid sediment transportation would have required a host of miracles, including somehow maintaining the compositional purity of thousands of massive stockpiles of loose sediment in the face of fantastic turbulence and global currents. Again, something that is completely nonsensical. The geology of the Grand Canyon is known fairly well after nearly 150 years of careful field and laboratory studies. The geological evidence, only a fraction of which has been described in this podcast, is overwhelmingly inconsistent with flood geology, which indicates that stratigraphy was deposited in the span of less than 1 year during a global flood. Despite the claims of flood geologists, the rocks reveal multiple episodes of deposition and intervening periods of erosion. Every formation can easily be explained by analogy to modern depositional environments such as the open sea, coastlines, estuaries, and sand deserts. The condition and distribution of fossils in the stratigraphy do not reflect the rapid burial of sea animals and small land animals out of deep, turbulent water. Flood geologists have failed to conceive a physical model for catastrophic formations that is consistent with the real geology of the Grand Canyon. It's not my intention to settle the question of how to interpret the Genesis flood story. However, as responsible Earth scientists, we are motivated to give the public an honest accounting for the origins of the most glorious piece of creation. If you're interested in learning more about this topic, do make sure you read the book, The Grand Canyon, Monument to an Ancient Earth. It was used to help me create this podcast with a wealth of knowledge and illustrations. Wow, well, we covered quite a lot in today's episode, and I hope you really enjoyed it. And I'm going to end it here, and thank you for listening. Don't forget to follow and hit that notification bell. I'm your host, Mr. Earth Guy, and remember, stay curious.